Okay, I'm going to do some extra solutions to some problems in the example set that you were given. The first one is on acceleration in 2D. I'm going to use x and y components in this solution, and it is a question looking simply just for acceleration. It's John walks through Central Park. So it gives his initial velocity, 3.5 meters per second. V2, he speeds up to 4.5. His direction is also changed in 1.2 seconds, looking for acceleration. So following the standard solution process, the first thing that we do is define a positive direction. In this case, we'll say north and east. But you know that if you chose something different, you would still get the correct answer at the end. Second thing that we do when we solve with x and y components is we sketch the vectors. I'm going to do it off on the side here. So 45 degrees east of north would look something like this. And that would be my y component. There would be my x component right there. 3.5 degrees, similar with the second velocity, 12 degrees south of east. This time that would look like here, 4.5. So at least you can see everything. There's my x component, there's my y component. Okay. Going to start selection by breaking it up into x sides and y sides, remembering that the formula for acceleration is essentially the first step is to find v2 minus v1 in the x direction and v2 minus v1 in the y direction. We'll worry about the time later. So v2x, if I just write that down to start, it's going to be 4.5 cos 12. v1x, 3.5 sine of 45. 45 degrees, it doesn't matter whether we did sine or cos, but in this particular case it is directly across from the angle. Here, across from the 45 degrees, so we'll call it sine. Looking at positive and negatives, because I said east was positive, both of these will be positive numbers, both x components are positive. So finding what we call delta v, or if I say delta vx equals v2x minus v1x, just do the subtraction, and you get a number about 1.927. We'll leave the units here for this to put it in at the end. In the y direction, using exactly the same strategy, v2y, this time is a negative number. It's heading down, and we said north was positive. It's heading south, and north was positive, so it's going to be minus 4.5. It's across from 12 degrees, so it's going to be minus 4.5 sine 12. The 1y is a positive, and it's going to be 3.5 cos 45. So, change in v in the y direction, v2y minus v1y, and it works out to about negative 3.4. Okay, so we have our x component or y component. We're going to find our overall change in v by drawing a right angle triangle. Remember, the strategy is to put your pencil down, start drawing the x, add the y to it without lifting up. So 1.927 in the x, y is negative, it's going to come down like this. 1.927. And my overall change in v is right there. An angle. So change in v, using the Pythagorean theorem, 1.927 squared for 1 squared works out to 3.92 about. Remembering that depending on how many decimal places you hold throughout, you might get a slightly different answer. The more decimal places, the better. If you could do your whole solution using sines and cosines right until the very end, you'd get the most accurate answer. So what I'm saying is, instead of solving here, you would actually just leave it in terms of sine and cosine until you put it into the Pythagorean theorem. That would be ideal, but it doesn't have to be that way. Okay, Theta, in this case, is going to be tan minus 1 opposite over adjacent, so that would be 3.41 over 1.927 equals about 60 degrees. That gives us an acceleration then that will be equal to v2 minus v1, so it's 3.92 meters per second, 60 degrees south of east, over our change in time, which was 1.2 seconds. So the final answer is about 3.3 meters per second squared. 60 degrees south of east. Okay, that's just one more problem. And maybe the good thing to do would be to turn this solution off, go try it on your own, and see if you can get the same answer.